Hi, today we're going to go over lesson 10.4, the AA similarity theorem. So, whenever we talk about similarity, let's review. Similarity means something about the sides and something about the angles. So, whenever we have two figures that are similar, that means that the angles are all corresponding and equal, and that the sides are proportional. Okay, now we're going to have a few shortcuts. Now, we don't want to have to prove every set of angles correspond and are equal, and every set of sides are corresponding and proportional. We don't want to do that every single time. So there's three shortcuts, and today we're going to talk about the first one. It's called the AA similarity theorem. Now, of course, you can call this theorem 44. I usually just call it the AA similarity theorem, or just AA. Now, this is the easiest shortcut ever. If two angles of one triangle are equal to two angles of another triangle, then the triangles are similar. Now, this is really nice because you don't have to do a proportion and check the side lengths. You just can look at it and say, hey, do you have at least two sets of sides that are corresponding and congruent or equal? And as you can see on this one, we do. So angle S and angle M, they're corresponding and congruent. R and L corresponding congruent. So we're finished. Now, technically, if there's two angles that are congruent, we know there's technically three angles because we subtract from 180 and they have to be the same thing. But again, we're only going to prove two. If you prove two, then the triangles are similar. Now, guys, this only works for triangles. Now, let's look up here. If two angles of a triangle, so don't try to apply this to like a quadrilateral because the same rules don't apply. Okay, so again, this works for triangles. At least two angles have to be corresponding and congruent. Now, I bet you know the answer. We only know one way, but let's list what we know. Now, first of all, there are two triangles here. We have this tinier triangle at the top, and then we have this big triangle here. Now, we know X and Y are the same measurement. They're listed for us. So X is the same thing as angle Y. But what else do we know? Now, we technically only have to prove one other thing. Maybe we can just talk about both of the other angles just so we can. Now, this symbol here means that the lines are parallel. So that's a hint. If the lines are parallel and this is your transversal, that means these two angles have to be equal because they're corresponding. So angle V is equal to angle Z because of the lines are parallel and they form corresponding angles. Now we have another one. Now, we have this little triangle up here, and let's change colors up. We have this bigger triangle. If you notice, when I trace those, there's one angle both triangles have in common, and that is angle W. Angle W is equal to angle W because it is reflexive. So yes, we often have reflexive sides. Angles can also be reflexive. So this is the reflexive property. So I thought it was worth pointing out. All right, so for this part, we're going to grab a calculator and we're just going to simply say whether or not the triangles are similar. And if they are similar, we're going to write a similarity statement. So we know this angle here has to be 35 degrees because they're vertical angles. So for this triangle on the left, I'm going to take 180 minus 100 minus 35 to see what angle Z is equal to. So when I do that, I get 45 degrees. Now, I instantly know this works because I see over here, this is 45 degrees. So that means those are equal. I know the 35s are equal. You could do the math, but we're going to get 100 regardless. We have to prove 2. So yes, this is I almost said congruent, similar by a similarity. And let's write our similarity statement. Remember, the first one could be in any order. I'm just going to say ZAE. Now go by the angle measures. Z corresponds with B, A with R, and E with E. Now, keep in mind the triangles can be different sizes now, so you can't just look at it and say, oh, different sizes doesn't work. Let's find this one. So I'm going to take 180 minus 110 minus 35. So I get 35. Okay, so there's a 35 and there's 35. So does it work? What do you guys think? Of course it doesn't, right? Because this one is 25 and this one is 35. So it's just simply, it doesn't work. And you could do this one up here. If I take 180 minus 25 minus 35, I get 120, not the same. So these are not similar. I don't think there's an I in similar. Okay. Now, the last one, actually it's B, I skipped it. There's no information here, but this one is just like the one we did on the prior page. If you have parallel lines, that technically means you have corresponding angles. So you could just prove those and be finished. Or we could say angle M is reflexive with itself because M is part of this little triangle. And if I change colors, you can see M is part of this bigger triangle. So yes, this one works. This is a similarity. MST is similar to MLN. Okay, this is the last slide of the notes. The corollary to the AA theorem, if two triangles are similar to a third triangle, okay, let me start over. Two triangles similar to a third triangle are similar to each other. Okay. Now, I tried to write this out for you, and there should be little triangle signs in front. I just couldn't get them to go on my paper. Okay, so triangle ABC, the first one here, is similar to triangle DEF. That's given to you. And then triangle DEF, which is the second one, is similar to GHI, which is the third one. So by this corollary, we know, therefore, the first triangle, triangle ABC, is going to be similar to the last triangle, GHI. So it's kind of like substitution, but it's with similarity in triangles. So there you go. All right. So that is it for today. Please let me know if you have any questions.